Hi, everyone. My name is Rennie. I wanted to thank Sid and the AMS group down in Atlanta for having me tonight. I am re-recording this presentation because this may have been my fault, but we fell to the victims of a Zoom bomb because kids have nothing better to do these days. Darn kids and their skateboards. Anyways, I agreed to give the presentation again, just so it's a more of a clean edit, and maybe my words will be better too. We shall see. All right, I'm gonna go share my screen now, and okay, and now sharing the presentation. All right, so the title of my slide tonight was called Asheville, North Carolina, Climate City. So again, my name is Rennie. I'm a research meteorologist. That's not the official term anyone's given me. It's sort of the term I've given myself. And we'll kind of talk about that in a little bit. So meteorologist kind of comes with a stigma, as some of you all know. There's sort of an expectation for sort of a reality as to what I do. So when I tell my family that I'm a meteorologist, they think I'm either one of two things. Either this person, who is, of all apologies to Paul Goodloe of the Weather Channel, but I do not ever want to do this. I believe this is when he was hurricane chasing for either Irma or Maria back in 2017, trying to, I guess, check the wind speed. I would dislocate a shoulder if I've ever done this, so this is not something I want to do. The other stigma is that people, they always ask, well, what channel are you on? Are you on TV? Nope, I'm not in front of a green screen. Actually, not even with my Zoom background, I'm not in front of a green screen. I respect the people that do that, and I have done it before at my local college, but it's just something that I don't do. But my office is actually this. It's pretty much cubicle world. Bunch of computers, computer programming languages on there, a couple books, a phone. It's exciting times. Well, this actually isn't my office right now. My office is more like this because I've been working from home for the past 3.5 months. Yes, there is a crib on the bed. Do not ask why. And this is my 4-year-old, who does not sleep in that crib, mind you. But he came to visit us during one of our meetings. So it's a different kind of Zoom bombing, but that's the one I appreciate the most. But this is basically, what I do. I just have cubicle life, just munching away at computer code, and it's pretty awesome. Quick background about myself. I'm originally from New England, just outside of Boston, Mass. My Boston accent doesn't always come out, but when it does, it's amazing. I'll sound like these people from that Super Bowl commercial. Everyone has a weather story. My weather story is not necessarily different from everyone else. I was caught in a weather event. Most people, their weather event is, a big hurricane, big tornado, big snowstorm, blizzard. Mine was just a simple squall-like thunderstorm that just came right through while we were camping overnight. Kind of startled me overnight as a young kid. And ever since that moment, I decided I wanted to check the weather before any camping trip. I always check the Weather Channel, local on the 8s. And then when it came time to do college, I decided, well, it was time. Okay, I think a weather forecaster is something I want to do. I want to work for the National Weather Service. I want to, issue those severe thunderstorm warnings and tornado warnings and special weather statements and AFDs. That's all I really wanted to do. So I went to a small school in New Hampshire called Plymouth State University. I got my bachelor's degree in 2008. I stayed for my master's degree, got that in 2010. I did a couple internships along the way. I was a NOAA hauling scholar in 2007. I worked at the Weather Service office in Oklahoma, in Norman. And then in 2009, I did a NASA internship down at Cape Canaveral Air Force Station. They and their major objective is to forecast launch operations. They were actually very busy a couple weeks ago doing the launch for the joint SpaceX NASA launch that they did. And so I actually worked with them. I did a research project looking at microbursts, and more specifically the winds that come from the microburst, because lightning's a big hazard in Florida, but wind is the number 2 most devastating event that can happen there, because you don't want $1 billion SpaceX payload to get knocked down by some wind. So they are very interested in microburst activity. And during my research, I actually got a lot of data from the National Climatic Data Center, or NCDC as it was called. And one thing led to another. And after I got my degree, I ended up getting a job down there. And down there is in Asheville, North Carolina. So that's where I'm located now. It's about 4 hour drive from Atlanta. And like I said, we're located in downtown Asheville. It's this big federal building that you may have seen online. And their big objective, the National Centers for Environmental Information, their objective is to archive all the weather data. So at the end of the day, when the reports are done, whether it's cooperative, well, the reports are never done, but when, once a cooperative observer has made their report, once the satellite data sends their data down, once the radar data has come through, we archive it. We archive all of it. And I don't have official numbers, but the last time I checked is that we have over 40 petabytes of data. That's like some insane numbers, like 8,000 laptops or something. And it's growing exponentially. And we have it all in Asheville. Now, this building here has many different tenants. NOAA is the number one tenant, the National Center for Environmental Information. There's other companies in there. The Weather Squadron is in there, part of the DoD. They do climatological forecasting for operations around the world. There's a bunch of contractors that work with the federal government. And then there's sort of where I work, and that's actually NC State. So we're called, here comes another acronym here, we're called the North Carolina Institute for Climate Studies, or NCICS for short. We're like a cooperative institute. So some of the bigger cooperative institutes is the mesoscale one in Oklahoma, the satellite one in Wisconsin, and then Ceres out in Colorado. So we work with a federal entity. We're funded by federal entities, but we're not federal. We're tied to a university. So in our case, we're tied to NC State. So there's about 35 of us, made up of meteorologists, software developers, graphic artists, science communicators. Our vision is to inspire cutting-edge research and collaboration with not only NCEI, but other partners. We advance the understanding of current and future state of the climate, and then we engage with local businesses and academia, governments, and the public to enhance public decision-making. And I'm going to talk a little bit about all that with what we do. Okay, what do I do? So my background's in meteorology. So if someone gave me a GFS map, I could probably predict the weather, but I haven't done actual forecasting in so long, probably not since college. So usually when someone asks me, what's the weather going to be like tomorrow in Asheville, I go, yeah, just go to the weather service. They're going to be much better at it than I am. So please don't ask me about tomorrow's forecast. I'm more like a computer programmer. So, we take all this data from NCI and do something with it. Now, depending on the project, it can incorporate a lot of things, pulling in data from other countries, analyzing data to some extent, making pretty plots, which I'll show. I'll talk more about that part. But we are an academic institution, so we write about it in journal articles, even newspaper articles in some cases. We talk about it. We go to scientific conferences. We give outreach to students, and we do outreach to chapters of AMS, just like this. And we get paid to do it. And it's a lot of fun. I really like it. I consider myself a data nerd. And that's what I do, is I just be a data nerd. So it's pretty amazing working here. So just some examples of what I do. This is one of our most famous charts that come out of NCI every month. They do a monthly climate report, talk about the state of the climate, mostly temperature and precip, but other things like drought and other weather events that have happened around the world. This is a map from May 2020 showing how warm or how cold it was compared to some sort of context. So this is the most recent one that was released. And you can see, the eastern U.S., Atlanta, Asheville, others, experience much cooler than normal temperatures for the month of May. But it's, it's not just the eastern U.S., it's the whole world. So, other parts of the United States and other parts of the world, especially over the oceans, saw significant warming during this month. So just one of the reports that's released. I'm on the team that helps develop this. I don't technically make this image. They don't let me make a fancy plot like this. I make more something like this. This is actually all the land and buoy data that goes into that product called GHCN. Another acronym, sorry about that. It's the Global Historical Climatology Network. It encompasses many different networks. So the most common ones in the United States are the Cooperative Observer Program, ASOS stations at airports, AWOS. We have COCORAs in there. And then we have a lot of global data as well, because it's a global network. So we pull in data from weather service offices all across the world and other consolidated data sets that groups like the Met Office and others have pulled in already. I should point out that while I am an avid fan of pretty plots, that's not all we do. We do data set generation, and with data set generation, there is a lot of documentation. I am not going to ask anyone about what's on this graph, but the point of this is that there's lots of code and lots of processes that go into making this, and documentation is key, because if something breaks, we need to go back and figure out, okay, what piece of code broke it? What are the dependencies? What is it going to mess up down the road? And when it happens, and trust me, it does happen, it's good to have something like this. And so this is just the point, is that not, we don't do pretty plots all the time. Although I like to say I do, but we have to keep in mind that documentation is important. And quality control is important as well. This is an example of a different project I work on. This is actually with FEMO. They have a database of Snowfall Extremes, and they asked us to vet it using some of our data. And so we found this record one day for King County, Washington, that said that it snowed 45 inches in one day. Okay, maybe, highly unlikely, but it's plausible. But we looked at stations nearby, and we saw, oh, okay, most of these stations have values between 0 and 10, whereas this one specific value, is 45. What gives? Well, it turns out that not only do we have archived digital data, but we've also archived all the paper records that go into it, if we have it. So, the Cooperative Observer Program has been around since the late 1800s, and, they didn't have computers back then, so they wrote everything down on paper. And so we actually archive all that information in our basement. We have all these paper records. So we actually are able to look at the paper records and see, and sort of vet some of these questions here. So this is the same data, but on paper form. This is for Stevens Pass, which is that station in question. And on the third line here, it actually says that 4.5 inches only fell on that day. So something happened when it got digitized, whether, somebody forgot the period or the machine read it wrong. But essentially this 10-to-1 issue, which is actually very common, occurred. And our automated quality control did not catch this. So it's important that these paper records are there to help us kind of vet the results, and it's also a way to see who has good handwriting or not. But no, this was a good example of paper records saving our butts. We do other work. We do research. We do long-term research. So in the context of climate change, we'll do decadal trends and such. This is an example of heat waves. As we know, heat is the #1 killer of weather-related incidents in the U.S. And we wanted to see, okay, well, we know that they're #1 killer. We know that temperatures are increasing over time, but what's actually happening to heat waves? They're probably increasing, but how are they increasing? Where are they increasing? Are they getting longer? Are they more intense? Are they more confined to a geographical area? And the answer to most of those questions are actually yes. And in this particular case, we're seeing that heat events are actually a lot higher in the southeastern US, so parts of Georgia, parts of Florida, and even parts of the Carolinas. But what's interesting about this map is that this is actually T-min. So this is overnight temperatures. So overnight heat waves are increasing. Now, somebody might ask, well, why should I care about that? I'm sleeping during this. Well, two things. One, you may not care because you're sleeping, or I may not care, but energy companies might care because the demand is much higher for electricity to have your ACs running, something that may not have been the case 20, 30 years ago. And then the other thing is for people that don't have air conditioners, or maybe they didn't need them 20, 30 years ago, but now they do, but they don't get them installed for whatever reason. And their bodies are having a hard time, acclimating to this warmer temperature. So energy companies are very interested in hearing things like that. So this is just an example of some published work that we did late last year. I've also been very interested in visualization of data. So, you might go to a website, get some climate data from somebody, and they give you an Excel spreadsheet. And then it's up to you, the user, to kind of go in and dig in and find trends and look at interesting things. But what if that was already publicly available? So that's kind of been my passion, is being able to take data and sort of view it in a way that is still scientifically sound, but is a little more easily digestible to the user. So these are just some examples here. So on the left are temperature and precipitation distributions for Atlanta. So I pulled this data for the Atlanta airport down there. And this is basically the year 2020 so far. So we're almost halfway through the year. We have temperature at the top and precipitation down at the bottom. And so temperature, first off, this is one specific year. So it's looking at max and min temperature against not only it's what is expected or it's normal, but also all the records. So a couple things to point out is that in early May, there was a couple nights in which it was actually really cold. It was in the lower 40s, and those were the record. It was either tied or broke the record overnight minimum temperature. So, somebody could run their own code and figure this out, but by being able to see the image here, it's a little bit kind of easier to pick off some of these obscure data points. And then this precipitation is actually an aggregated precipitation graph over time. And 2020 is plotted in black, but it's plotted against all of its other years. And a few other things. The yellow line is what is normal or what's expected. And then this dark blue line is what the record wettest year was. So according to this, it was 1948. So 2020, as it stands right now, is on par to be probably a really wet year. It's already higher. It's already higher than when it was in 1948 and any other year as well at this point. Now, I mean, we can't say for sure it's going to be the record wettest year. I mean, there might be a drought later this year that will, inhibit that, but it can tell us that so far this year been much higher than normal than all the other years. I've been very interested in GIS capabilities. So this is actually plotting some dew point data on a spatial map. This isn't anything extremely new, but I know a lot of people are interested in point and click observations. So we're in a time of COVID. So a lot of the data that's being produced by Johns Hopkins and other websites are using these online interactive GIS-based tools, whether it's from Esri or QGIS or others. And I've been very interested in doing things like that. And then finally, Ed Hawkins famously made this thing called climate stripes a couple of years ago, where, you may have seen, your typical, annual trend in temperature. It's, it might go up, but, there's parts of ups and downs and then a big shift at the end. But maybe from the public's perspective, they don't know what that means. But what Ed did is that he just turned them into stripes, into red and blue stripes. And on a global scale, you could see the stark difference between the cooler past and the warmer present. And there was just a big thing last week, called Show Your Stripes, where, you can go to a website and get your country, state information and produce the stripe. Well, I thought, we have this data at NCI and we have this data down at the county level. So why not just do it for every county in the US? And, in the programming world, if you do it once, you can do it 3,000 times. So that's essentially what we did is we produced stripes for every county in the US. This is actually Fulton County, Georgia, where Atlanta or part of Atlanta is located. I know there's Cobb County and others, but this is just another way of visualizing data for public digestion. And that's something I've been very passionate about. And then, speaking of the public, I like to go out and give talks. So I like giving talks to you all here at the AMS chapter. I have given talks to kids from ages 8 to 80. So I've gone to elementary schools, I've gone to colleges, we go to science fairs, outreach events. This is actually most of our outreach team, going out and giving presentations to some people. Not only is my hair much shorter, I am not as good giving selfies. So I'm just not that great at it. But no, we do go out and talk to the public. But we do so much more. We generate reports. We just helped release a report called the North Carolina Climate Science Report that actually was part of an executive order issued by our governor, Roy Cooper. So we actually helped aiding that along with the state climate office and all other entities within the state system. We are also a big heavy hand in the big data project that NOAA is producing. So, we have over 40 petabytes of data at NCI, but everyone's looking to the cloud, whether it's Amazon or Google, but we've gotten contracts from them to help push some of our data into the cloud. The NextRad archive was sort of the first one, and we actually did that. And we're still pushing more and more data now. I think we just really recently pushed out all of the NDFD data out there. And then finally, we also do some sort of forecasting. So we don't do a typical 7-a-day forecast like the Weather Service, but we'll do subseasonal, going out on the order of a few weeks, if not a few months. This is a tropical meteorology page, and it's showing observed data first and then sort of the forecast. So you can actually see here's Bertha, Crystal Ball, Amanda. These are weekly sort of averages of information. It's actually precipitable water. And it's trying to relate, okay, what area, you're most likely seeing high areas of precipitable water during tropical cyclone events. And then, forecasting that out to see, are there areas of, anomalously high values that could help aid in tropical formation, whether it's tropical cyclones or, monsoons and such. So, one of our colleagues, his name is Carl Schreck. He's the master at making these, but that's some forecasting we do, but we're not stepping on the toes in the Weather Service, I promise. And then finally, I just wanted to mention something called the Collider. So we are, I work for NC State and we work with NCEI. So you've got sort of the academic sector and you've got the government sector. Then there's also, there's the broadcast sector where, your local channels, our local channels, you have a broadcast meteorologist giving the report and giving out their forecast. But then there's the other sector called the private sector. And, in the meteorology world, we all know, there's the weather company, there's AccuWeather, there's DTN, there's WeatherBell. There's a whole bunch of places that are, trying to do public-private partnerships of, disseminating weather information and forecasts. Well, in climate science, the same thing is starting to happen. And, NOAA has all this data. Some of it, and it's starting to move to the cloud. And a lot of companies are very interested in taking this data and using it for something. And that something can be a lot of things. It could be, it could be climate related. It could be health related. It could be, anything. I'm thinking like Lowe's or Home Depot, they might want that information. The weather and climate is such, a big entity in the distribution process for, sending trucks across the country for lumber or, airline travel, so a lot of people are interested in this climatological data. So a company kind of grew out of that called the Collider, and they're actually a few blocks from NCEI. And they, we kind of, or at least I kind of coined them as sort of the private sector of climate data science. And there's many, many different companies there that work there that leverage our data and, send that out to, partners. So a couple of examples is there's this one here called Daily Breath. They're big about creating an app for asthma, and they want to know air quality information. And they use, some of the data that was provided by NCEI. Another one is Prescient Weather. They do some sort of, they're another example of doing subseasonal forecasting where they will go out and, get companies to, talk to companies about, how they should invest in something because things are going to be drier over the next few months or things like that. Many, many, many different companies. There's also the American Association of State Climatologists. So every state, most states have a state climatologist. I know Georgia does, North Carolina does. So they can be members of this association. And actually they're headquartered here in Asheville. And then there's this one little company here called Rennie Weather, which is my private gig on the side where I'm a certified consulting meteorologist. So I do some consulting meteorology on the side. So just one little pitch there. So that's all I have. Thank you. Speaking of climate stripes, I produced this last week during the Show Your Stripes campaign. This is for the entire state of Georgia with a GIS shapefile of your state in the front. Thank you all for listening to me. Here's my email. Here's my Twitter account if you want to find me. So I'm gonna keep it on here for a second because when we did the Zoom call earlier, there were a couple questions that popped up before we got Zoom bombed the heck out of there. So I'm gonna try to address those questions. I'm gonna try to remember them off the top of my head. So one question was about the subseasonal forecasting, which I explained in a little bit more detail about what we do. GFS, NAM models, Euro, that's the Weather Services realm. That's, producing 7 to 10 day forecasts for, temperature, precipitation, wind, cloud cover, things like that. Subseasonal forecasting it varies, but in the specific case I showed you in this map here, this is more for tropical meteorology, for hurricane formation, tropical cyclone formation, and even monsoons. In this particular example, this is precipitable water, but we look at other things like outgoing long wave radiation, Kelvin waves, Madden-Julian oscillation, Imagine oscillation is really interesting because I'm going to botch this. So apologies to my colleague Carl Schreck if you're listening or watching that. You could have a particular event that occurs in India may affect precipitation patterns in the U.S. a few days later. So it's like ENSO, but much shorter time scale. So that's what these maps sort of provide. So that's sort of like the sub-seasonal forecasting that we work on. There's other ones that like the Climate Prediction Center do for long range, 3-month, 6-month outlooks of temperature and precipitation departures, but we don't necessarily do that here. And then the other question is, do we use GitHub? The answer is yes. Yes, but it depends. NOAA is, they're required to have their code available in case anybody asks for it. They're slowly transitioning over to GitHub, but it is something they're considering. Who I work for, the institution NKICS, we do have GetLab, which is a branch of GitHub, and we have code repositories. And if nothing else, it saves our butts. Sometimes I'll accidentally remove a directory unintentionally and I'll have to get my code back. So GitLab and GitHub have been very helpful. And then the last question before we sort of got kicked off was, what programming language do people use? And the answer is that it depends. There isn't one that dominates the other. I could argue all day about, what you could use and what not, but it really doesn't matter. You can, as long as you do good work and make pretty images or do sound science, it doesn't really matter. I personally use Python. I found it to be very resourceful and very useful and also free as when I was in college. But I know people that have used R, MATLAB, IDL, NCL, Fortran, Bash, Perl. I could keep going, but they're all fine. But I think the question was, what do I use? And most of my stuff is in Python. Okay, so I am going to stop my presentation. And okay, I think you guys are back on me, but I just wanted to say again, thank you so much for having me. I really enjoy doing these things. Thanks to the Atlanta chapter. I think this is the second talk out of a series of a few, and they've got a lot of great people coming up, so feel free to check them out. And I got nothing else, so I hope you all have a good day, stay safe, and maybe we'll see each other.